Hey, I want to do a quick video about something that we talked about in class earlier today when we were doing an optimization problem. We said that if you have a given length of fence and if you want to enclose a rectangular area with that fence, that you can get the most area out of it, right? You can maximize the area by taking the fence and cutting it into 4 pieces and making a square out of it. So that means that this is L over 4. And we came up with that each side should be L over 4, and that made a square. And that was kind of easy to believe that this was the best set of dimensions if it is going to have the most area, because it says it's the most circle-like that it can be. But then we did another problem where if you took the same length of fence and you built the pen along like a wall or a river's edge or a cliff or a barn side or something, that the configuration that gave you the most area was no longer a square, but it was a setup where it was twice as long against the given side as it was away from it, so that this would be L over 4 and this would be 1/4 of the side of the whole length, and this turned out to be L over 2. So we said that this side turned out to be twice as long as this, and that was less intuitive, right? Because since the square, it just didn't make sense why, if it's being made along a certain side, that it should distort itself like that, as opposed to making a square. Let me move this around like so, where all the sides are equal. So in that case, this would be L over 3. And L over 3 and L over 3, right? If you divide it into 3 pieces, that makes a square with the given side. It wasn't obvious that this was the one that we were talking about, but I just wanted to show you that it really is true, and there is a good it might not be intuitive, but there is an intuitive reason behind it. If we take this, the area of the rectangle is length times height, so that's L squared over 16. That's the most that you're going to get. And if you arrange it like this, if you're building it up against a wall, then the area is going to be length times width, so that'll be L squared over 8. That's a larger number, right? You actually get more area if you arrange it like that than if you try to make a square out of it, in which case, right, this would be L squared over 9. Now the largest of these is L squared over 8 because it's got the smallest denominator and the numerators all match. But the reason that in this particular setup, if you're given a wall, that it's made like this and not like this, aside from the fact that mathematically it doesn't work, is you should think about it as being given, as being already just having more fence. Right? If you're making it along a wall with the same given length of fence, then it's like you're sort of like you're getting provided this side of the pen for free. So, which allows you to use the remaining fence, which once would have had to have been bent into a square. You only need all this fence to make only 3 sides, because the 4th side is essentially given to you. Something else that I thought was pretty neat about this is that there is, if you're given this length of fence, there's only, say that you're given an infinite wall up against which to make this pen. Alright, so you're given an infinite wall and some other finite length of fence. There is only this much fence will actually do, only this much wall will actually do you any good, right? Any more than this length that you get for free, like this stuff out here and this stuff out here, that's just going to be wasted. So I thought it was kind of funny that even if you're given an infinite length and a finite amount of fence, if you can't bend it at some point, it's gonna go to waste. The only other fence is good because you can configure that in any way that you want to. But any more than half of the total length of fence that you're given, if you can't bend it, is just gonna go to waste. This is pretty cool because this could lead you to examine some other kinds of problems, such as what would it be if instead of being given an infinite length here against which to build the fence, if you're given a corner, say, right? Now, if you're given a corner, what length of fence is going to maximize it now? How are you going to best capitalize on using this corner? Could you use it? I mean, clearly this, I believe, is going to make a square. I haven't looked into it, but it seems obvious to me that if you already have that bend there, infinite length here, then you'll be able to distribute. This will be just L over 2 and L over 2, and the best that you're going to get out of that is going to be L squared over 4. And that's even better, right? Because it's even larger than this, because now you're given two sides with which to work, and you can use the remaining fence on just those last 2 sides. But that's the explanation as to why it's not bent into a square, just because mathematically the way that it works out, and you can see it as being provided a length of fence for free.